Assalamualaikum warahmatullahi wabarakatuh. Good day to all viewers. This time, I'm going to present to you how to find the derivative of a product. But before that, let us first define what is derivative. Derivative is the process of finding the derivative of a given function is called differentiation. And if the function f is defined by the equation y is equal to f of x, then the derivative of f can be denoted by any of the following symbols. Okay, so finding the derivative of a function, we use a technique by applying some of the basic theorems on differentiation. Theorem number 1 is the derivative of a constant. If f of x is equal to c for all x where c is a constant, then f prime of x is equal to 0. Applying this theorem, so number 1, f of x is equal to 8, then f prime of x is equal to 0. Number 2, f of x is equal to negative 1/2, then f prime of x is equal to 0. In short, the derivative of a constant is just equal to 0. Theorem number 2. Theorem number 2, if r is a rational number and f of x is equal to x raised to the power of r, then f prime of x is equal to r times xr minus 1. Apply this theorem. Number 1, f of x is equal to x raised to the power of negative 1/5, where negative 1/5 is in a form of a rational number. Then the derivative is f prime of x is equal to, bring down the negative 1/2, so negative 1/2 x negative 1/5 rather, negative 1/5 minus 1 is equal to negative 1/5 x negative 6/5. Just the same with the constant. If r is a constant, say for example, we have g of x is equal to x cubed, then g prime of x is equal to, bring down the constant 3, then x3 minus 1 is equal to 2. So that's a theorem number 2. Okay, so number 3 theorem. Number 3, if f is a differentiable function and f of x is equal to c times f of x, where c is a constant, then f is differentiable, then and f prime of x is equal to c times f prime of x. Applying this theorem, so f of x is equal to negative 5x raised to the power of negative 3, then if prime of x is equal to the constant negative 5 remain, then the derivative of your f of x, which is x negative 3, applying the theorem number 2, so you bring down the exponent, so we have negative 3 and x is negative 3 minus 1, which is equal to negative 5 times negative 3 is 15. Then x negative 3 minus negative 1 is negative 4. So this is now our derivative. So that's theorem number 3. Theorem number 4. Theorem number 4 is a derivative of a sum. If f and g are differentiable function, and h of x is equal to f of x plus g of x, then h is a differentiable function and h prime of x is just equal to the derivative of x, f of x plus the derivative of g of x. So let us apply this theorem. Theorem number 4, we have number 1, h of x is equal to 2x raised to the power of 5 minus 11x plus 4. Then the derivative h prime of x is equal to, rewrite the constant, then bring down the exponent. So we have 5, then x is 5 minus 1 minus 11 x minus 1 minus 1 plus the derivative of the constant is just 0, which is equal to 2 times 5 is equal to 10. X is equal to 5 minus 1 is 4 minus 11, then x is 1 minus 1 is 0, then plus 0, no need to write. Then we have 10x raised to the power of 4 minus x raised to the power of 0. Any number raised to the power of 0 is just 1. So 1 times 11 is just 11. So this is now our derivative of the function 2x to the 5 minus 11x plus 4. That's the theorem number 4, the derivative of the sum. So now, let us go to our main goal, the derivative of a product. So the derivative of a product, we have theorem number 5, derivative of a product if f and g are differentiable and h of x is equal to f of x times g of x, then h is a differentiable and h prime of x is equal to f of x times the derivative of g of x plus g of x times the derivative of f of x. Let us apply this theorem number 5. We have this example. H of x is equal to 3x squared plus 1 multiplied by 3x minus 2. This is our f of x and this is our g of x. So the derivative is, you rewrite the f of x. So we have 3x squared plus 1 times the derivative of g of x, which is 3 minus this one is just a constant, so 0, and this is 3 because bring down the exponent 1, so 1 times 3 is just 3, then x raised to the power of 0 is just 1, so 1 times 3 is just 3, plus the g of x, which is 3x minus 2 multiply by the derivative of your f of x. So rewrite 3, bring down the exponent 2, so 2x, 2 minus 1 is just 2 minus 1 plus the derivative of constant is just 0. Then simplify 3x squared plus 1. 3 minus 0 is 3 plus 3x minus 2 multiplied by this one. 3 times 2 is 6. Then x, 2 minus 1 is just x plus 0 is just 6x. In this case, we are going to use distribution law. And distribution law distribute 3 on this part. So 3 times 3x squared is 9x squared plus 3 times 1 is 3 plus 3x times 6x is 18x squared. 6x times negative 2 is just negative 12x. So in this case, we are going to add the like term. So we have 9x squared plus 18x squared is 27x squared. Then negative 12x plus 3. So we arrive in this part, which is the derivative of the function h of x is equal to 3x squared plus 1 multiplied by our g of x, 3x minus 2. So that's all for today. Catch me on the next video on the other theorem.